Hey guys, let's work some problems from Alex practice lesson 3.3. So the first problem says find the distance between point G and H. And so we can see point G is right here, point H is right here. I can look and see that that's a 3 and that's a -3. And so the distance between here and here is actually 6. And that's all there is to that when they're straight up and down. Okay, number 2 says find the distance between the points 6 and -4 and 6 and 3. And actually we can see that since these 6's are the same, they're going to line up pretty nicely. So 6 and -4 is like here, and then 6, let's say this is 6, and 3 is like here. So we had 3 here, and then down to -4 is 4, and so the distance is going to be 7. Number 3. After crossing a bridge, Ivan drives at a constant speed. Okay, all lines are constant situations. The graph below shows the distance in miles versus the time since he crossed the bridge in hours. So we have time and hours, and there's some more to this problem here. So how much does the distance increase for each hour since Ivan crossed the bridge? And then what is the slope of the line? Those are going to be the same thing, but let's have a look here. So whenever I go over 1 hour, I have to go up to 75. And so I am going 75 miles per 1 hour. Let's just check that with the 2. Here's the 2. We go up here to 150. So that would be 150 miles per 2 hours. And if we simplified this, we would get that. So that's the constant rate that's happening. So in each hour, we are going 75 miles. And so the slope of this line is 75 miles per hour. So we're going to type in 75. And we are going to type in 75. All right, number 4. Find the slope of the line graphed below. So it's often very helpful when they put dots on these little intersections because sometimes it's hard, like, in a place like this, it's hard to see exactly where the line is crossing. But this line is at -1 and -1. And this, did I say line? I mean dot. And this dot is at 1 and -4. And so there's a couple of things I can do here. I'm going to show you both. So if I want to use the slope formula, I can do this. I'm going to do y2 minus y1 over 1 minus -1. Look at all those negatives. That's like crazy. So we actually have -3 over 2. Okay, so here's the other way I want to talk about doing this. If I draw a triangle, and it doesn't matter whether you draw the triangle above it or below it. Oops. Let's only go this far. Draw a triangle to those dots like that. It's a right triangle. Notice that I have gone 2 spaces this way, and this is 3 spaces, and I'm going down. And so whenever I'm going down, I always want to use a negative. And so I want to go negative, rise, over run, which happens to be 3 is the rise over 2 is the run. And we have calculated that 2 ways. You pick. Okay. I hope that's what that was. I'm slightly starting to forget. Okay, find the slope of the line passing through these points. So this time we're going to use the slope formula. Excuse me. And I'm going to do this formula y2 minus y1 over x2 minus x1. And so 4 minus a negative 3 over negative 3 minus negative 8. So this is my pattern. Y2 minus y1 over x2 minus x1. Now I just have to deal with all these negatives. Lean on your calculator a little bit if you're not super accurate with these things. We have 7 on the top, 5 on the bottom. So the slope of the line is 7/5. Look for part 2 for problems 6 through 10.